Hey everyone, in this video, I would like to talk about how to use Stewart's theorem for competition math. So I got to give you the picture, right? So here's the drawn picture of a triangle. All right, so here we go. We got some M and N, and the whole side length right here is going to be A, and this is going to be D, and that's going to be B, and this is going to be C. All right, so there must be some people who already know how to actually remember the Stewart's theorem. Well, this is what's going to happen, right? So we usually say man and his dad put a bomb in the sink, all right? So we have man and his dad, they put a bomb in the sink. All right, so this is how we use Stewart's theorem. And for this line segment that we just connected a vertex by any point on the opposite side, we usually call it as Sevian. All right, so we usually call this line segment as Sevian. And of course, the most important, out of the most important Sevians, well, I would say we can think about some altitude and we can think about the median, but other than that, or probably the angled bisector, but it's just like, in general, we just call them Sevian. Right, so how do we prove this? Right, so we got to be able to prove this. So here's what we're going to do. We're going to set up angle equation. We're going to call this as theta. And of course, that's going to be 180 minus theta, right? So we would like to call this as phi. And if I just set up just the angle equation, then we get theta plus phi equals 180. So we can actually write it as theta equals 180 minus phi. All right, so let's use the law of cosine. So how do I use the law of cosine? The first, for this triangle, the obtuse triangle that we have, well, we can actually say that cosine phi, right? So we have cosine phi will be, in fact, 2dn, and we got d squared minus n squared minus b squared, right? So that's the very first information that we can get using the law of cosine. At the same time, we can use the law of cosine for the other triangle. And that other triangle is just going to be cosine theta. Well, you can check that cosine theta is going to be cosine 180 minus phi. Forget about how we're going to switch those cosine theta into some relevant information about cosine phi. But first, we know that cosine theta is going to be 2 times d times m. Well, that's just going to be d squared plus m squared minus c squared. All right, so here we go. What do we know about this theta and like phi? Well, the sum becomes 180, or we can say these are supplementary. So that means cosine phi plus cosine theta is in fact 0. That's what you can know. Well, because if they're supplementary, then, unlike sine, the cosines are going to have the different signs, I would say. So that's why we can actually get 0 for here. So we're going to just substitute these fractions into it. And let's see what happens, right? So we have d squared plus n squared minus b squared over 2dn. And we have 2dm. And we can multiply, we have d squared and m squared. We don't multiply yet. We get 0. All right, so here's what's going to happen, right? So we're going to actually multiply every fraction, or even the right side, by, well, probably 2dmn, right? So if I multiply everything out here by 2dmn, well, we can check that we're just multiplying d squared and m plus m n squared minus b squared m plus, what happens for this one? Well, d squared times n, and we have m squared times n, and we get n times c squared. Okay, so let's just try to combine what we have. D squared m plus n, d squared times m plus n, and we have mn squared. Well, I would say that becomes m times n, m plus n, right? So that shall be b squared m plus c squared n. So we can rearrange all of these. And by the way, from our picture, let's shrink this picture right here. You guys can check this again. Well, you can check that m plus n, in fact, that turns out to be a. So we're just going to bring it all the way up here. And we're going to multiply this by d squared times a. And we get mn times a, which turns out to be b squared m plus c squared and n. And there's an easy way to remember this, right? Well, just as I told you in the very beginning of this video, I told you that D-A-D, dad. And there's man, right? There's man. Well, they put a bomb in the sink.